Hey, this is problem number 19 in the Energy Review. In the previous problem, we talked about a Honda FCX Clarity, and given some real data, we were asked to find out how far it could go on a tank full, and we figured out it could go 70 miles. In this question, it says, based on the bond energies, how many joules of energy were produced during combustion? This is a real car that's available for lease that consumes hydrogen. And here's a balanced chemical equation for the combustion of hydrogen. We'd like to know the enthalpy for this reaction based on the bond energies. In other words, we're going to break all these bonds, we're going to make all these bonds, and we'll compare their enthalpies to come up with a amount of heat at constant pressure that should be released by this combustion reaction. The data is not shown in this problem, but you can look it up and you should find that for as written, for this sort of a molar basis, 2 moles of hydrogen, we have to break hydrogen bonds 2 moles worth. So each hydrogen bond has a bond energy of 436 kilojoules per mole. I've left out the units to keep things simple. I probably shouldn't do that, but there you go. And it's 872 kilojoules to burn those 2 moles of hydrogen. That is to break those bonds. We're also breaking a mole's worth of doubly bonded oxygen. That's 498 kilojoules per mole. That's the energy in. Let's calculate the energy out. We give it a negative sign to imply an exothermic process. And we have 2 moles worth of water. However, every water molecule has 2 hydrogen to oxygen bonds each. Therefore, we multiply by 4. And when you run this through, you'll find out, not surprisingly, it's exothermic and to the degree of 486 kilojoules for every run through. I can't really say per mole of hydrogen because it's per 2 moles of hydrogen. It is for every mole of oxygen. Therefore, it's true for 2 moles of hydrogen, which is 4 grams of hydrogen, but I don't really need that. I do know that I have, from the previous problem, 500 moles of hydrogen. And if this is kilojoules for every 2 moles and I have 500 moles, I'll be multiplying by 250 and get a whopping number of basically 12,162,000 joules, or 12,162 kilojoules of energy are produced by this combustion reaction. This is the summary review problem in the energy unit, problem number 19.